Okay, in number 4 and number 5, we solve problems regarding elastic collision. So you have objects that collide and separated afterwards. Starting with problem number 6 and 7, we are going to have problems on inelastic collision. Let us look at number 6. An astronaut at rest in space with a mass of 84 kilograms fires a thruster that expels 35 grams of hot gas at 875 meters per second. Okay, so let us imagine that this is the astronaut, okay, holding a thruster. In space, you would not be able to uh, travel without firing thrusters, because if you want to move in this direction to the right, you have to direct your thruster to the left, okay, and vice versa. So in this case, the astronaut is directing the thruster to the left, so he wants to move to the right. Okay, so initially it is at rest, so V is equal to 0. Initially they are together, the gas and the astronaut, so that's going to be M1 plus M2 times V. Okay, let M1 be the mass of the astronaut, 84 kilograms. Let M2 be the mass of the gas, that's 35 grams. Okay, so it follows that since they are both at rest, V is equal to 0. So this is before the explosion, then equals after they exploded, they separated. Okay, so this is reverse inelastic. Because initially, the gas and this astronaut, they are together. Okay, so after the explosion, the gas is directed to the left, right? So in this direction, yung gas, and that's going to be our M2, no? Uh, so M1 is 84 kilograms. We expect V1 to be positive because we assume that it's heading to the right. So they should be in the opposite direction. So M1 V1 prime, which we are looking for V1 prime, plus M2, the mass, which is 35 grams, but we have to convert that to kilograms, multiplied by V2 prime. V2 prime, we know the value, it's negative 875 meters per second. So we want to solve for, okay, this one becomes 0. We want to solve for V1 prime. Okay, so V1 prime is equal to negative 0.035 because we're moving this to the left side of the equation, so positive becomes negative. But V2 prime has a negative value, negative 875 meters per second. Okay, divided by the kilograms in V1 prime. So, okay, this one is already in kilograms. Okay, so we multiply 0.035 times 875 divided by 84, we get 0.364. So V1 prime is equal to 0.3645 meters per second. Okay, let us follow the rules on significant digits. This will be 0.36 meters per second. This is the speed of the astronaut, and he's heading to the right. Okay, let us go to number 7. Number 7, a 5.0 gram bullet is fired with a velocity of 100 meters per second towards a 10.0 kilogram stationary solid block resting on a frictionless surface. Okay, what is the change in momentum of the bullet if it is embedded in the block? Okay, so let us illustrate this first. So you have the mass of the bullet, M1, is 5.00 grams. The velocity of the bullet, V1, is 100 meters per second. Okay, so stationary block. So this is at rest, M2, 10.0 kilogram, but V2 is equal to 0. And then what happens is after they collided, nag-stop na siya. Okay, embedded lang, no? So we assume that there is no motion after the collision. So this is our bullet heading towards the block, no? So we do m1 v1 plus m2 v2 is equal to, it's embedded, so they combine m1 m2 v prime. But v prime is equal to 0 because the bullet was embedded. So we substitute M1, it's 5 grams. Convert that, you get 0.005 kilograms. The speed is positive 100 meters per second. Okay. Okay. This problem is just solving for change in momentum. Okay, so initial momentum of the 5 gram 0.005 kilogram bullet is 0.005 times 100. Okay, so 0.005 times 100. Okay, so it's zero point 0.5. Okay, zero point 0.5 kilogram meter per second. But the P final is equal to 0. So the change in momentum is equal to P final minus the initial 0.5 kilogram meter per second. So negative 0.5 kilogram meters per second. It's negative 0.5 kilogram meter per second. Letter B, what is the change in momentum of the bullet if it ricochets in the opposite direction with a speed of 99 meters per second, almost the same speed as it had originally. Okay, so delta P is equal to PF minus PI. Okay, we have solved for the P initial. The P final, we can find P final is equal to 0.005 kilograms. But this time, we substitute 99 meters per second. So if it's first heading to the right, left naman siya. So 99 meters per second. You get an answer. Negative 0.495 kilogram meter per second. Okay, so P final is negative 0.495 kilogram meter per second minus our P initial is this one, negative zero point 0.5 kilogram meter per second. Okay, so what is the change in momentum here? So negative negative will be positive. We get 5 times 10 raised to negative 3 kilogram meter per second. Okay. We follow the rules on significant digits. This is 1 SF. Okay, so 100 meters. No, so 1 SF lang. Okay.